Hi viewers, you are welcome to Oasis Online Math. Today we shall be solving this indicial equation. Merely looking at this, it looks kind of a bogus, but if you apply your laws very well, you are going to get it correctly. From our left hand side, we have 1 over m raised to the power of 1 minus x is equal to m raised to the power of 3x plus 1, everything all over m raised to the power of 2x plus 5 over 2, and to the square root of m raised to the power of 2x minus 1. Let's start from our left hand side. Let's turn this fraction to index as well. That is, this fraction we can turn it to index. That is, what do I mean by that? We can manipulate this to give us an index form, so that we have don't forget that when you have a raised to the power of 1 over a raised to the power of n is the same thing as it's the same thing as a raised to the power of minus n. So we can simplify it in that way as well, so that we have our left hand side in index form. Let's do it that way. So we have m raised to the power of minus 1. Don't forget it's having this power. So we have 1 minus x. Then is equal to m raised to the power of 3x plus 1. Everything all over this. And don't forget that this expression you have at the bottom here, at the denominator here, they are multiplying each other. So we have m raised to the power of 2x plus 5 over 2 multiplied by, now let's express this as well. This inside the square root sign. Then don't forget anything in square root sign, meaning that it is raised to the power of 1 over 2. So we have m 2x minus 1 all raised to the power of 1 over 2. So if we simplify that further, we see what we have. So in our left hand side we shall have m raised to the power of minus 1. Using minus 1 to clear the bracket, we have minus 1 plus x, because minus times minus gives us plus. So we have in our right hand side we have m raised to the power of 3x plus 1, everything all over what we have there in our denominator. Everything all over what we have here in our denominator. So we shall have this to be m raised to the power of 3x plus 5 over 2. So let's write it in a simpler form. We have m raised to the power of 2x plus 5 over 2, okay, multiplied by m raised to the power of, so if we use our if we use our half to multiply 2x minus 1, we shall have 2x minus 1, everything divided by 2. So we have, let's rewrite our left hand side. We can write our left hand side as m raised to the power of x minus 1. Yeah, of course, it's acceptable. So we have our right hand side to be m raised to the power of 3x plus 1, everything all over. And don't forget, the sign between this is multiplication. So therefore, we pick one base and add their power. So we have m raised to the power of 2x plus 5 over 2, then plus 2x minus 1, everything over 2. So that is the power we have in our denominator. Then let's go further. So we must make sure we resolve this denominator very well, so that we can have a very beautiful simplification. So we have, in our left hand side we have m raised to the power of x minus 1 is equal to, we write our numerator back, 3x plus 1, everything all over m. Now if you want to solve this expression we have here is the same thing as linear equation. And actually we've dealt with linear equation in our previous video, more especially linear equation involving fraction and that of bracket. So here, what we are expected to do here is to make all this fraction, to remove all this fraction. And how do we clear our fraction? By multiply 2 by our denominator. We can write this to be 2x over 1, like as well. So our LCM here, which is Denominator is here, we have 1, 2, 2. So our LCM definitely is equal to 2. So if you multiply 2 by 2, you multiply all the terms here by 2, we shall have it to be 2 into the bracket of 2x over 1 plus 2 into the bracket of 5 over 2 plus 2 to the bracket of whole fraction that we have there, 2x minus 1. Note that they are all together. Then we can simply agree that our values here will definitely be reduced. That is, it will be simplified as we have it here. So we have in our left hand side, we have m raised to the power of x minus 1 is equal to m raised to the power of 3x plus 1, everything all over. Then we can simplify further here. Then we have 2 times 2x, we shall have 4x plus, definitely these two we cancel these two, we are left with ordinary 5. Likewise, we have these two, cut out these two, then we are left with ordinary 2x minus 1. So let's simplify further. You can see that these are like times, 4x and 2x. So we have in our left hand side, we shall have our left hand side remain as m raised to the power of x minus 1 is equal to, then m raised to the power of 3x plus 1. Let's write our division sign here. Then let's write our denominator, which is m raised to the power of, then 4x plus 2x here, we shall have 6x, then plus 5 minus 1, we shall have ordinary plus 4. You can see. So therefore, we can see what we have here is now looking so simple that we can easily address. So let's go. We have on our left hand side, we have m raised to the power of x minus 1 is equal to, we pick one base using our laws of indices. That is, when they are multiplying, when two numbers are multiplying each other, we shall pick one base and subtract the base of the denominator from the numerator. So in as much the division sign is between them. So we have 3x plus 1 plus 1 plus 1, then minus, please do open a bracket, we have 6x plus 4. Okay, then when we have m raised to the power of x minus 1 is equal to m raised to the power of 3x plus 1. Then when we clear the bracket, we have minus 6x, then minus 4. You can see now that that bogus Indicial equation is now looking well refined and simple. So we have m raised to the power of x minus 1 is equal to m raised to the power of, we have 3x here, we have minus 6 here, so we have minus 3x, plus 3x minus 6 here, we shall have minus 3x, then we have plus 1 here, plus minus 4, we shall have minus 3. So hence, merely looking at our left hand side and the right hand side, you will see that we have simplified them such that they share the same base. Hence you can see the base, we cancel out this base here. We are left with the powers. And what are their powers that we have here? We have ordinary x minus 1 is equal to minus 3x minus 3. Then we can easily collect the right hand, bringing minus 3x to this side. If we bring minus 3x to this side, we shall have x plus 3x, then is equal to minus 3. Then bringing minus 1 to this side becomes plus 1. So we have plus 1. So here we have 4x is equal to minus 2. If 4x is equal to minus 2, then it means that our x, to obtain that, we can divide both sides by 4. Then our x will definitely be 1, 2 here, 1, then 2 here, 2. Our final answer is 1 over 2. This is the final answer. It looks bogus, but when you apply your laws one after the other, step by step, you definitely get the answer correctly. Thank you for watching. Do make sure you subscribe to our YouTube channel. Follow us on Facebook channel as well. Thank you. God bless you. Bye for now.